What is up, Chem Peeps? Let's manipulate the equilibrium constant. Consider the chemical equation and equilibrium constant for the synthesis of ammonia at 25 degrees Celsius. Equilibrium constant 5.6 times 10 to the 5. Calculate the equilibrium constant for the following reaction at 25 degrees Celsius. Pause. Compare the two equations. Recognize that the second equation is the reverse of the first equation and has been multiplied by a factor of 1/2. Therefore, K prime, or the equilibrium constant of this new equation, is equal to 1 over the equilibrium constant of our initial reaction because we reversed it, and then that value is going to be raised to the 1/2 power because we've multiplied it by a factor of 1/2. K prime equal to 1 over 5.6 times 10 to the 5 to the 1/2 power. Calculator. 1 divided by parentheses 5.6. Second E. 5 close parentheses enter. Enter raised to the 1/2 power. Enter. K prime equals 1.3 times 10 to the minus 3. Boom. Pause. Take a moment. Reflect. It makes sense that our equilibrium constant of the second equation is less than 1 because it's the reverse of the first equation. The first equation was product favored, so the reverse of that is going to be reactant favored. K less than 1. Oh, math. Consider the following chemical equation equilibrium constant at 25 degrees Celsius. Calculate the equilibrium constant for the following reaction at 25 degrees Celsius. Take a moment, pause the vid, compare the two equations. Recognize the second equation has been reversed and multiplied by a factor of 2. K prime equals 1 over our initial equilibrium constant. Because we reversed it, that value will then be squared because we multiplied it by a factor of 2. K prime equals 1 over 2.2 times 10 to the 6. That value squared because we multiplied it by a factor of 2. Calculator. 1 over new parentheses 2.2 second E 6 close parentheses enter. Square that out. K prime equals 2.1 times 10 to the negative 13. Boom.